I've sent out the work solution. Some students have queried the clarity of these solutions, so I'm going to try to do this video by putting up the question and their work solution and try and work our way through what they've done. Now, I've just bought this tablet. Anything could happen here. I'm just still learning to use this thing, so it's a bit of an adventure. We'll see what happens. Now, question 1, we've got 60 metres of fencing is used to build a rectangular enclosure along an existing fence. So here's the existing fence. Okay, so you don't have to fence that side. Now, suppose the sides adjacent to the existing fence are X metres long. So they've chosen to make, so the existing fence, the new fence is what I've done in blue there, and they've chosen to make that length there X metres long. What we're trying to do here is we're trying to get an expression for the area in terms of that one variable X, because then we can find if there's a stationary point, in other words a local max or minimum. In this case it'll be, we're looking for a maximum. What value of X gives us the maximum area of this enclosure? Okay, now if we get the area in terms of that variable X, we can use calculus to find out what the maximum is by finding a stationary point. So they're leading us through it. They want us to find this expression. All right. So we've got that length as X there, and that means that this length here is also X. Now there's 60 metres of fencing. It told us that. There. What does that leave for the length along here? Well, it leaves 60 minus what we've used, which is X plus X. So it's 60 minus 2X, because we've used up 2X metres. So this length must be our total, 60 minus 2X. Okay, now we know the area of a rectangle is length times width, so it should be X times that 60 minus 2X. Okay. Now they called that length Y here and then said that 2X plus Y must be equal to our 60 metres. I took a bit of a shortcut and said that, all right, if that's X and that's X, this must be 60 minus that. And that's what they've come to here, that length is 60 minus 2X. Now they're up to finding the area. Area is the width times the length, X times Y, so it's X times that 60 minus 2X. And so our area is equal to X times 60 minus 2X. Okay, and that's what I would have done here. Length times width, X times the 60 minus 2X. So that's how they did part A. Now it says find the dimensions which maximise the area of the enclosure. Well, this is where the calculus comes into it. So we need to differentiate that function. They've expanded it to make the derivative easier down here. 60 times X is 60X. X times 2X is 2X squared. So there's our function we're going to differentiate. So the derivative of 60X is 60, and the derivative of 2X squared is 4X. So that's our derivative function there, 60 minus 4X. Now we need to find any stationary points, because that's where a maximum or a minimum will occur. So we need to equate the derivative to 0. So that's what they've done here. 60 minus 4X equals 0. Solving that gives you X is 15. So that's this stationary point here. Now they've done the sign diagram. X can't be negative, and X can't be bigger than 30 if you think about it, because if X was 30, you'd have 2 times 30 up here. Whoops, where's this pen gone? 2 times 30 up here is 60, and you'd have a length of 0. So x any bigger than that, and you're going to have a negative length. So it's got to be between 0 and 30, but you don't really have to put that in. Now we need the signs. So if x was less than 15, let's say it was 10, 60 here minus, so I'll do this in a different colour. So we're looking to find that sign there, and we get it if x was 10, then you'd have 60 minus 4 times 10 here would be 20. So it's positive there. So I'll rub that out now, it gets a bit in the way. So we know that it's, pen. We know it's positive there, that's what they've got. Come on, pen. And I did mention that that factor came from this one here, that's an odd power, so there'll be a sign shown, so it's negative there. But you can test it. Put in 20 for x, 60 minus 4 times 20 is 60 minus 80 is negative. So that sign diagram situation gives us a local max at that point. Now, so the area is maximised when x is equal to 15. And they've probably gone on to get the dimensions under that, but it's probably easier for me to just finish it here. So we've got a rectangle that is 15 metres there. So what's this length? 60 minus 2x is 60 minus 2 times 15. That's 60 minus 30, which is 30 metres. So let's get rid of that. That's going to be 30 metres. So the dimensions are 15 metres by 30 metres, and the maximum area you can get is going to be 15 times by 30. What's that? 450 metres squared, if I've got that right. Yeah. Okay, so I don't know if this approach, putting up these solutions and then explaining them, or just doing the problem, give me some feedback. Probably sometimes it's going to be better this way, sometimes better if I do the problem from scratch. But anyway, I'll post this one. Now this is in OneNote inside the Teams. So the reason I got this tablet is so I can do these things over OneNote. The iPad wouldn't do that. And that way the actual finished image is documented in OneNote, and I'll put the video in there as well, a link to it. Okay.